Okay guys, welcome everyone. From this lecture series I'm gonna start with MCQs. So in the previous two parts I had explained the complete basics and I have given all kinds of formulas with respect to this. From here I'll start with the MCQs related question. Calculate the static indeterminacy of the frame which is shown below. So the given thing is frames. First thing you need to make sure whether the given structure, okay, after seeing the question, the first thing you need to confirm is whether the structure which is given here is pin jointed plane frame or rigid jointed plane frame here, okay. But in this, just by seeing we can get it, and they have a frame. The given thing is frame. In case if they have given the truss is nothing but pin jointed plane frame. That is the first thing you need to clear. So after clearing that, come up with the formula, and here they are asking us to find static indeterminacy of a plane frame. So ds is equal to dse plus dsi. So dse is equal to r minus 3. Is it right? So the total number of reactions here is for fixed support, the total number of reaction is 3, and for roller support it is 1. So 3 plus 1 is equal to 4. 4 minus 3, which is equal to 1. The value of dse will be 1. Second thing, the degree of internal static indeterminacy is equal to 3c. Okay, 3 into number of closed loops. Since there is no hybrid joints present here, minus RR. Of course, this is formula. RR is equal to 0 because the hybrid joints is not present. And 3 into the total number of closed loops. See, this loop is open. Okay, but this is closed loop. Okay, total number of closed loop is 1. So it comes to be 3. Total ds will be equal to dsc plus dsi, that is equal to 1 plus 3, which will be equal to 4. So 4 is the right answer. So one more direct formula I was given you. ds is equal to 3m plus r minus 3j. If you put for this formula, substitute for this formula also you'll get. So once we'll do. So what is m? Total number of members which is present here. So 1. How to find the members is very important. See, this is one member. Okay, 1, 2, 3, 4 from every node to node. 1, 2, 3, 4, 5, 6. Total number of members is 6. Then how to find the number of joints? See, these are joints. 1, 2, 3, 4, 5, 6. The total number of joints is equal to 6, and 3 into m, 3 into 6 plus r is how much? 3 plus 1 is equal to 4 minus 3 times the joint is equal to 6. This comes to be 6 3 is 18, 18 plus 4 22 minus 6 2 is 12, 6 3 is 18. So this comes to be 4. If you calculate by this process also it will be right. This process also it will be right. Sometimes what happens, instead of static indeterminacy they may ask you to find internal static indeterminacy or external static indeterminacy. In those cases you go for this process. If they ask direct thing, you go for direct this formula, so that it will save your time. But one thing, this process, this first process and second process, both the steps you need to know. The question may be altered in any of the manner. Okay, that's all. So let's move to the next question. Determine the static indeterminacy of a following pin jointed trusses. Okay, first step, you need to confirm whether the given structure is pin jointed structure or pin jointed trusses or rigid jointed plane frame or pin jointed. So the given thing here is pin jointed trusses, which is nothing but a trusses, and you need to go for the trusses formula. That is, okay, you need to follow this formula in this condition. Please make a note of this. Okay, ds is equal to dse plus dsi. First, DSC, which is equal to R minus 3, total number of reaction. In hinged support it will be 2, in roller support it will be 1, in roller support it will be 1, 2, 3, 4, which is equal to 4 minus 3, which is equal to 1. Then we need to find the value for DSI, where value formula for DSI is equal to m minus of 2j minus 3. Since that given structure is not 3D, it is pin jointed plane frame itself, so it is a 2D structure, m minus of 2j minus 3. Now we need to find the number of members and number of joints. So number of members is 1, 2, 3, 4, 5, 6. Okay, this consider the complete 7, 8. Okay, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the total number of members is 20. See, in this case, okay, please take, it will be like two cases. Okay, you can take in both the ways. If you take 1, 2, 3, 4, total 5 and 6. If total member of is 6, then you are not supposed to find this joint. In this case, the joint become 1, 2, 3, 4 itself. But if you take like this 1, 2, 3, 4, 5, 6, 7, 8, like this also it can be taken. In this case, the total number of joints has to be taken as 1, 2, 3, 4, and this joint has to be considered. Please make a difference between these two things. In which method you are comfortable, please follow that method. But I am comfortable with this first method, so I am going with this method. Then total number of joints 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, I am not considering these three joints because my method is first method. If I had done in the second method, I would have taken this joints. That is the difference. So in all the upcoming questions, I'll go with the first method, and if you want to cross check, you do with the second method. And if you are not supposed to get the same answer, please do comment me in the comment section, and I will clear your doubts. So it comes to be total number of members 20 minus of 2 into 10. It comes to be 20 minus 3, which comes to be 3. The total DS is equal to DSI 1 plus 3, which is equal to 4. And we can also apply direct formula, which is equal to m minus of, okay, one small correction. In the previous part I had told this formula, these two formula doesn't holds good. Please delete it. Only you can calculate the value of DS by following this method, only one method. Okay, in case of pin jointed plane frame. So answer for this question would be 4. A very simple question. Calculate the static indeterminacy. So first thing we need to confirm one thing, whether this is truss or frame. Of course, by seeing this we can tell it is frame. This is not a pin jointed truss. So the first step, DSE. To find DSE, total number of reaction minus 3, which is equal to the total number of reaction for fixed support here 3 and here 3, it comes to be 6. 6 minus 3 would be 3. Then we need to find the value for DSI. DSI will be equal to 3 into number of closed loops, which is equal to the total number of closed loops is equal to 0 here, because there is no closed loop, it comes to be 0, and value of DS is equal to DSE plus DSI, it comes to be 3. So answer is 3. Next question. A simply supported beam having an internal hinge is of course it will be mechanism. I'll explain how it is mechanism. See, I'm just taking one simply supported beam and there is a presence of internal hinge here. If internal hinge is present between the simply supported beam, it forms a mechanism. Okay, this mechanism concept will be studied thoroughly in plastic analysis topic. In this case, what happens, degree of static indeterminacy will be -1. and the structure, if the internal hinge is present, then the structure will be unstable. The simply supported beam with an internal hinge is of course unstable. The deflected profile forms a linear mechanism. So simply supported beam having an internal hinge is a mechanism. Elastic structure analysis makes use of. The elastic structure analysis will be like this. If I can draw a graph, if this is stress and if this is strain, then the loading portion will be like this, and this would be the unloading portion in this direction. On unloading anything, the deformation shall be recovered completely in the similar direction to that of loading. If you are loading something, the strain, that is the material is getting expanded, and if you are unloading the thing, it regains its original position. So linear stress strain relation, so elastic linear stress strain relationship would be the right answer. So very important thing with respect to one of the chart I had given, they are asking us to find whether the structure is indeterminate or unstable or stable or determinate. The first thing we need to find, so since it is a frame, DSE which is equal to R minus 3, where total number of reaction for hinges it will be 2 and for this it will be 1, total number is 3. 3 minus 3, it comes to be 0. DSE external static indeterminacy, and internal static indeterminacy would be 3 times the closed loops minus RR. You need to take RR, that is because internal hinges is present here. So internal hinges like this, so value of RR will be equal to m minus 1. The total number of members which is meeting the hinge will be 2 minus 1, which is equal to 1, which was explained in the previous video. So coming into the C, there is no closed loop, so 3 into 0 minus 1, so DSI will be equal to minus 1. So the total DS will be equal to this plus this, so it comes to be minus 1. First thing, this can also be calculated in the another formula, that is DS is equal to 3m plus R minus 3j. You'll get, you need to get the same answer which you have got here. So the total number of member here is equal to, oh, you need to add one more thing, that is minus RR. The total number of member is 1, 2 and 3. Total number of joint will be equal to 1 joint, 2 joint, 3 joint, 4 joint, and value of RR is already calculated, which is equal to 1, which is equal to 3 into m. Total number of members is 3 plus R is equal to, what is the 2 plus 1, which will be equal to 3, minus 3 into total number of joints is equal to 4 minus redundant reaction, that is equal to 1. So if you calculate this, you will get 1, I mean minus 1. So that is the confirmation between these two things. Then in order to find this, let me go to the chart which I had explained. If the value of DS is less than 0, it is determinate and unstable. So what the value we have got here is DS is less than 0. In this case, what happens? It is determinate but unstable. So first, statically indeterminate and but unstable, no. Determinate and stable, no. It is unstable. And you can add one more point here, it is determinate. If they have given determinate and unstable, this is the right answer. In this manner you need to solve this question. Yeah, this is just a practice questions. Let us see. Calculate the static indeterminacy of the frames, which is given here. I'll just directly put the formula 3m plus R minus 3j. So total number of members here is equal to, in the seventh question, total number of members is 3 into 1, 2, 3, 3 members, 3 into 3, plus the total number of reaction is, here it is 3 and here it is, since it is hinge, it is 2. 3 plus 2 is equal to 5 minus 3 into total number of joints. Total number of joints is 1, 2, 3, 4. So it is 4 and minus RR is not there since there is no internal hinges present in this problem. So if you calculate the value, you will get it as, so the answer would be 2 for this question. Normally these types of question will be asked. in the second thing, of course ds is equal to 3m plus r minus 3j. I am solving the 8th question, minus rr comes into account because there is a presence of internal hinge here, which is equal to 3 into total number of members is equal to 1 3. Total number of members is how much? 1 member, 2 member, 3 member. Okay, don't separate this member 1 2 like that. This is 1 member, this is 2 member, and this is third member, plus total number of reaction here 3, here 3, it would be 6, minus 3 times number of joints is 1 2 3 4. 4 numbers of joints is present, minus redundant reaction m minus 1. Total m is total number of members meeting the hinge 1 2, which is 2 minus 1, which is equal to 1, and if you calculate you will get the value as 2. See how simple it is. Then coming into the 9th question, same you need to find with ds is equal to 3m plus r minus 3j minus rr. For cross checking you can follow the other step which I had explained, which is equal to 3 into total number of 1 2 3 3 members. What is the total number of reaction? Here 3 and here it is 2. 3 plus 2 is equal to 5, minus 3 times the joint 1 2 3 4 joint, minus m minus 1 is equal to 2. Sorry, redundant reaction would be 1. So if you calculate this, the answer will come to be 1. So that's all guys. The remaining thing we'll see in the remaining MCQs will see in the next part. Thank you one and all.